Now, how do we actually compute these types of things for images? How can we actually deblur images that are actually because of focus? So here are two different sets of examples. These are actually approaches proposed by Levin et al. In 2007. Basically, the two methods they proposed is one, exploit prior information on natural images. Look and model the types of signal deconvolutions that happen for natural images like this, and actually use that to figure out depth discontinuities and discrimination that will allow us to improve deconvolution and also depth estimation. So, natural images are scenes like this. Unnatural images would be, random noise types of things. The other method, and this is the one we'll actually focus on in this lecture, is basically come up with different patterns and then basically use these patterns on the lens itself. So make a defocus pattern that is known. In this case, it's the aperture itself. But change the defocus pattern to have some sort of a characteristic like this and use that to discriminate where the defocus is differently for different planes of defocus planes in an image. Again, we'll talk about this in a lot more detail, and the idea really comes up is that what we want to do is come up with a coded aperture, an aperture that would have different characteristics like this, and you can put this inside a lens before the image is formed, amount of light that goes in through the lens to the sensor. If we can put this in, we can actually perhaps quantify the defocus on the sensor, and that will actually let us know how to deconvolve it based on the fact that we have actually quantified what the focus plane would be.